So now we're going to take a few minutes and work on reviewing with roots and radicals. So definition of square root, b is the square root of a if b squared is equal to a. So here we ask us to determine what the square root of 64 is. Well, 8 squared would be 64, so my answer would be 8. Square root of 25, well, we think of 5 times 5 is 25, so my answer would be 5. Square root of 1 over 81, well, square root of 1 is 1. Square root of 81 is 9, so that's 1 over 9. Notation for positive and negative square roots. The square root of a is the positive square root of a. The positive square root is also called the principal square root. Negative square root of a is the negative square root of a. And square root of 0 is going to be 0. And just note, a negative number cannot have a real number as a square root because no real number when squared is negative. So when they ask us what is the square root of 121, the way we write that notationally is we write it this way, and that would be 11. Now on your calculator you should have a square root key. So right here on the TI-30XS, it's the green above the x squared key. So if I wanted to take the square root of 121 on my calculator, I would type second x squared key. That gives me the square root symbol. And then I type 121. And that gives me 11. Similarly, if I want to do the square root of 49, I again can enter that very quickly on my calculator and get 7. Recall that the positive square root number is denoted by the radical sign, square root. The number under the square root is called the radicand. So here I'm taking the square root of 0.25, so second square root key 0.25, enter, that'd be 0.5. You can do this by hand or you can do it on your calculator. Let's do it on the calculator. So I hit my second square root key. I'm going to hit my fraction key here. Type 49 over 144. Going to make the calculator do all the work, so that'd be 7 over 12. And then 144 plus 25. And notice how I entered exactly how I see it. Hit enter. That's 13. In fact, if you take 144 plus 125, that does give you 169. And the square root of 169 is 13. So notice here that the square root kind of acts like a set of parentheses. I have to do the operations first underneath the square root before I take the square root. Now, simplifying square roots when the radicand is not a perfect square. Step 1, you have to find the prime factorization of the number under the radical. Circle pairs of the same factor you found in step 1. For each circle pair of prime factors, write one of the two of those factors outside the square root. Write any factors that are not circled underneath the radical. Multiply the factors outside the square root and multiply the remaining factors inside the square root to get your answer. Alright, so let's see how this works. So if we take the square root of 360, we'd break it down. That's 36 times 10. 36 is 6 times 6. 10 is 2 times 5. And then 6 is 2 times 3. So kind of putting everything together, we have 3 of these 2s, 2 of these 3s, and a 5. Step 2 is we circle the pairs of the same factors you found in step 1. So I circle a pair of 2s and circle a pair of 3s. For the circle pair, I write one factor out in front, write one factor out, and then I put these two remaining under the radical. If I then do 2 times 3 is 6, 2 times 5 is 10, that gives me 6 square root of 10. Now, if you're using the TI-30XS, notice what happens if I put in the square root of 360. It does all that work for me. 6 square root of 10. That makes life a lot easier. Alright, so we're going to do this by hand, and then we're going to do it on a calculator. So, if we're doing this by hand, I'm looking at 20, and this is going to be equal to 4 times 5, which is 2 times 2 times 5. So I have a pair of 2's. I'm going to write that out in front. Write one of them in front. I have a 5 left over. So that should be 2 square root of 5. If I'm doing 28, I'd write that as 4 times 7. The 4 is 2 times 2 times 7. I got a pair of 2's I'm going to circle, which I'm going to write one out in front. And then I have a 7 left over. Okay, let's look at 45. 45 is 15 times 3. 15 is 5 times 3. So I have a pair of 3's. That's going to go out in front. And I'm left with a 5 left over. Now, doing this on my TI-30. See if I can get this all in here. Get out the glare. If I do second square root of 20, hit enter, 2 square root of 5. Second square root of 28, 2 square root of 7. Second square root of 45, 3 square root of 5. Pretty easy. Alright, so now we're ready to talk about complex numbers in terms of I. So in mathematics, we define I to be equal to the square root of -1. That means that I squared is -1. So if b is a positive real, then the square root of -b equals I square root of b. So in the real numbers, we can't simplify this, but what we do is we go ahead and we first rewrite the expression in terms of I. Once we have it written in terms of I, then we can go and simplify it. So square root of -100 is I square root of 100. Square root of 100 is 10, so this simplifies to 10i. Again, this is not a real number, it's an imaginary or complex number. So square root of -36, this would be I square root of 36. So anytime when you get that negative out, we write it in terms of I. Square root of 36 is 6. So we get 6i. And for that last one, that becomes I square root of 36. That we can't simplify any further, so that's our answer. So here we're going to go and write each expression in terms of I and simplify. So I'm going to rewrite that as I square root of 75. And again, you can do this on your calculator if you have the TI-30XS. If not, We can handle it. We can rewrite that as I square root of 75 is 3 times 25, which is 3 times 5 times 5. Circle my 5, so the 5 will come out in front with the I. Square root of 3 would be underneath. Okay, so this, we write this in terms of I. And 48 would be 16 times 3. And here's a little bit of shortcut. Look at 16. Can you take the square root of 16? Yeah, that's 4. So that would be 4i, and then the 3 would stay underneath. So if you see that where you got a perfect square, you can pop it out. So we could have done that over here. I could have taken the square root of 25 as 5, put that out in front. Save you a step. Alright, so this is negative. This negative is outside, so that stays outside. I'm using the I to replace this. And then square root of 16 is 4, so that's a negative 4i. So this would be I times the square root of 49. Square root of 49 is 7, so that's just 7i. That's I square root of 50. 50 is 25 times 2. I can take the square root of 25, so that would be 5. Square root of 2. Now, if you try doing this on your calculator, like if I were trying to do that last one, if I hit second square root and put in negative 50, I'm going to get an error message. So before you do it on the calculator, you do have to write it in terms of I. So I'd have to write this as I times square root of 50, and then just work on simplifying the square root of 50 on the calculator. And just have to remember I have to put an I there next to the 5. Now for this last one, there's no I here because the negative's on the outside. In fact, if I wanted to, I could just go and pop that on my calculator. So that'd be 6 square root of 2. When Alex asks you to do the exact value, this is the form they want it in. They don't want you to do a decimal approximation. If they tell you, they would say round the answer to the nearest, blah, blah, place. If that were the case, then I've got this double arrow key down here I can hit. When I hit that, that gives me the decimal approximation. So here I'm going to write this in terms of I. And then that 8 I can write as square root of 4 times 2. Square root of 4 is 2, so that becomes 2 times 4i square root of 2, which is just 8i square root of 2. All right, let's try this next one. Here I cannot do the division because the 18 is underneath the root. I have to first write this in terms of I. $18 is 9 times 2. Square root of 9 is 3. Now I can divide out the 3's, because now that this 3 is on the outside, so that gives us I square root of 2. If I were to do that on my calculator, it'd be pretty straightforward. So I would do my fraction key. Just remember, you have to remember the I. So I'm just going to put the square root of 18, down arrow 3. So it gives me square root of 2, so I would just need to write my I on there. This is next one. This would be I square root of 54 over 6. 54 is 9 times 6. Square root of 9 is 3, so I can bring the 3 out in front. And then I can reduce these two numbers here. 3 over 6, that reduces to 1/2. So that'd be I square root of 6 over 2. That's as far as we can simplify it. Okay, we're getting there. We've seen this notation before, plus or minus. Now we're going to be seeing it a lot more in the coming lessons. But here I want to simplify. Now I cannot cross out the tenths because I've got more than one term in the numerator. What I need to do is I need to factor out the greatest common factor. Once I got rid of the product, I can reduce. So I'm going to factor out a common factor of 5. And now I can reduce. So it becomes negative 1 plus or minus 2 square root of 2 over 2. Now, the other way you could have done this is you could have taken that 10 and you could have done it in each term. So I'm going to put or. Negative 5 over 10 plus or minus 10 square root of 2 over 10. So you could do it that way, and that would simplify to negative 1/2 plus or minus square root of 2. And these are equivalent. If you were to put this in the calculator and then put this in the calculator, you would get the same thing. Let's try another one. So this is 6 plus or minus. Now let's simplify the square root of 32. If I think of 32, that's 16 times 2. And that would be 4 square root of 2. So now I can factor out 2 out of that numerator. And then 10 over 2 I can reduce by 2. That will give me 3 plus or minus 2 square root of 2 over 5. So again, we can write it that way. Sometimes in ALEKS, they might separate it out, write it as 3/5 plus or minus 2 square root of 2 over 2. So you just have to pay attention to the directions. Let's try this next one. Now notice on this one I can actually take the square root of 25. So that's going to simplify negative 2 plus or minus 5 over 4. Now remember what this notation means. It means 2 plus 5 over 4 or 2 minus 5. So these should be negative 2, my bad. Minus 5 over 4. And those I can actually simplify. Negative 2 plus 5 is 3. Negative 2, negative 5 is 7, or negative 7. So I actually can separate our answers out and get a negative 3/4 and a negative 7/4. Okay, so now when they say to write it in form a plus bi, we do have to separate the terms out. So what we're going to do is we're going to first write everything in terms of I that we need to. So I'm going to rewrite this I square root of 8 over 2. Square root of 8 is square root of 4 times 2. Square root of 4 is 2, so I'll have a 2 in front and a 2 underneath the radical. And now I'm going to need to divide that 2 into each term because they want an a plus bi. They want it separated. They don't want me to keep it as a fraction. So that gives me negative 4 plus or minus I square root of 2. Here we do the same thing. We'll go ahead and write that in terms of I. Square root of 64 is 8. So that'd be 8i over 4. And now I need to separate them out. 12 divided by 4 is 3. 8i divided by 4 is 2i. So that gives us plus 3 plus or minus 2i.